Welcome back to your physics lessons. If you thought my accent was confusing when you were in a classroom with me, just imagine what it's going to be like on YouTube. So this rota is really a follow-up to the last electricity topic we did. We were learning all about electric current flowing around circuits. And really the next lessons are all about the electricity you actually use at home, the mains electricity that comes out of our plug sockets. So for today's lesson, you're definitely going to be wanting a calculator, though you can probably use the calculator on your phone or tablet or device, whatever you want to do. And otherwise, you're going to be completing the worksheet that's attached to this lesson as we go along. So if you want to, you can open up a copy of that worksheet now and get that ready to type your work into. I'll give you opportunities to pause the video as we go along. If you have any questions or comments about any of these lessons that I'm posting, please leave me a comment on Google Classrooms to make sure I'll pick that up. So I'm going to get on with sharing my screen now and we'll get things started. So there's my screen, there's me flip charts. So let's get going. This first lesson is all about plugs and power. So the first thing I want to do is just quickly revisit one of the power calculations we actually did back in the energy topic way back at the start of our physics learning. And we said there was a formula triangle to learn for energy, power, and time. If you want to calculate the amount of energy that something transfers, you multiply its power in watts by the time it's running for in seconds. So you could use this for electrical things around your house. You might well spot a power rating on your microwave like 900W or on a light bulb like 40W for watts. And so that way we can work out the amount of energy transferred by those electrical devices. So I just want us to do a quick bit of practice using that EPT, Exciting Physics Teachers formula triangle. So when I'm using that, just like any other formula triangle, I'm just going to be covering up the quantity I want to calculate. Example calculation, calculate the power of a train that uses 2 million joules of chemical energy in 4 seconds. So if I'm calculating power, so look, there's my power. If I cover up the power, it leaves me energy divided by time. So power is energy divided by time. 2 million joules of energy divided by 4 seconds time gives me 500,000 watts of power. Another example calculation, a compact fluorescent light bulb transforms 64,800 joules every hour. What's its power? So let's have a look. Power, cover up the P in my formula triangle, leaves me energy divided by time. But the sneaky thing about this is that the time isn't given in seconds. I'm given 1 hour of time. So if I'm going to get my calculation right, I have to convert any times into seconds. You might be given a time in minutes or in hours, but you must convert those times into seconds. So 1 hour is 3,600 seconds. Power, 64,800 divided by 3,600 gives me a power of 18 watts. So in these calculations, keep an eye out for time that isn't given in seconds, but keep an eye out for things like kilowatts, which means 1,000 watts. Keep an eye out for things like kilojoules, which means 1,000 joules. All those conversions could be in there. So your worksheet, let's have a look. I think I've got a copy there. It's the copy of the worksheet you've got there. So the power, energy, time questions worksheet is the first task I'm going to ask you to do. It's got a grand total of 8 questions. The 8th one is an absolute beast. I will guarantee some green slips for anybody who submits a correct answer to that question with your working out. Whenever you're doing this worksheet, please make sure you show you're working out, just like I've done for the example for the first one. Calculate the power of a light bulb that uses 40 joules of electricity in 4 seconds. I've written out the formula I'm going to use. Power is energy divided by time. I've written out my calculation and I've given the correct units in my answer, 10 watts. So please make sure when you're setting out your calculations, they look like that. So now is a good time to get that worksheet use your calculator and complete those power, energy, time calculations. If you pause the video while you're doing that, I'll then go through the answers and you can mark and correct your calculation. So if you pause the video now, I'll come back to you with the answers. Okay, welcome back. So time to go through the answers to the calculation sheet. I'll get my answer sheet up here and we'll zoom in so we can see the answers a bit more closely. Okay, quickly through them then. So question number 1 I've done for you. Power is 40 divided by 4 gives you 10 watts. You're obviously getting a mark for the sum and a mark for the units. Number 2, 2000 watts. You needed to convert your 12 kilojoules into 12,000 joules to get the full marks on that one. Number 3, 1.67 or 1.6 continuous watts. You needed to convert the 15,000 kilojoules into 15 kilojoules into 15,000 joules, and the 2.5 hours needed converted into 9,000 seconds. Question 4, 1,250,000 joules. Question 5, 1,800 joules. You needed to convert your 1 minute into 60 seconds. Question 6, a standard form calculation. 4.32 times 10 to the power of 10 joules. So you needed to convert your 2 hours into 7,200 seconds. Question 7 is 3 seconds, standard form calculation. And question 8, the extension. If you got this one, really well done. First thing you needed to do was calculate how much energy was transferred. So that was power multiplied by time. And you needed to convert the 24 hours into seconds. So if you've done that calculation correctly, you should have figured out that it was 1.728 times 10 to the power of 10 joules of energy transferred. So you needed to work out how many litres of petrol that was. It told you the energy in 1 litre. So divided the total energy that you used by the energy in 1 litre. And to 1 decimal place, that comes out to 617.1 litres. So make sure that you have marked and corrected any of those before you submit that worksheet back to me. Right, let's get on with the next stage of the lesson. Next part of the lesson then is looking inside a plug. We've thought about the energy that comes in your electricity supply, but let's have a look how we actually get it into your house. Well, it comes in through a plug. And a plug here in the UK has 3 main wires and 3 main metal pins sticking out the back of it there. Now the 3 wires in a plug are the neutral wire over on this side here, the earth wire in the middle, and the live wire over on the right hand side. So I've got a neutral wire, blue, earth wire, yellow and green, and a live wire, which is brown. 3 wires in those, and they're each connected to one of the metal pins that sticks out the back of the plug. So the neutral pin, the earth pin, and the live pin. I can see there's a couple of extra features in the plug. For example, the live wire is connected to a fuse, little cylinder there connected to the live wire. I can see that to hold down the 3 wires that are wrapped together, there's a little, almost like a collar around a shirt, which is screwed down, called the cable grip, so that it's hard to pull those little wires out of the sockets if you accidentally pulled on the electric cable. And we call those 3 wires wrapped together the 3-core cable. And you've got the outside case of the plug, which is made from plastic. So we've got our 3 wires, if you remember them in order going around, N-E-L. N-E-L, I say my Auntie Nelly, N-E-L. So neutral, earth and live wires. The pins for each of those wires, the neutral pin, the earth pin and the live pin. And we've got the fuse and the cable grip there. And we would call the 3 wires wrapped together the 3-core cable and the plastic outer case. You'll need to learn the colors and orders of the wires in the plug. It's a really common question for a labeling question in the exam. If it helps you remember, BR for brown goes at the bottom right. So that's our live wire. And BL for the blue wire goes at the bottom left. That's our neutral blue wire. Blue neutral wire, yellow and green earth wire, and our brown live wire. Okay, so your job on the next worksheet that's attached here, we've got a 3-pin plug worksheet attached to the lesson. So your first job on that, the first page you can now complete, is filling in the names of the different parts of the 3-pin plug into the text boxes on that worksheet. Now you can obviously pause the video on this screen to help you get that labeling complete. And when you finish that labeling, you can unpause the video and we'll do the next stage. So your next job is to label the different parts of the 3-pin plug on your 3-pin plug worksheet. If you do that now, you can pause the video. Okay, welcome back. Thanks for getting the labeling done. Our next job is to actually look at what the jobs of those 3 wires is inside the plug. So our brown live wire, our yellow and green earth wire, and our blue neutral wire. Let's have a look at the live and the neutral wire first, because they are really what makes the circuit work in an electric plug. I think of the live wire as the wire which actually carries the current, carries the voltage into the plug. And it is it's the brown wire. And the special thing about it is it doesn't just carry the current straight in, it actually alternates. In other words, it's constantly switching between plus and minus voltage, plus, minus, plus, minus, plus, minus. A bit like someone taking one end of a seesaw and tipping it up and down and up and down and up and down. So the live wire actually has a voltage in it, plus, minus, plus, minus, plus, minus. So it carries in what we call an alternating voltage or alternating potential difference in from your plug. The neutral wire is then the other side of the circuit. It completes the circuit and it sits there at 0 volts. So it's a bit like one end of the seesaw is going up and down and up and down and up and down, but someone standing beside the seesaw is just standing there at 0 volts, watching someone be higher than them, then lower than them, then higher than them, then lower than them. They just sit there at 0. So the neutral wire sits there at 0 volts. It's the other side of the circuit. So our blue neutral wire completes the circuit and it's usually sitting there at 0 volts. Live wire alternating or changing between plus and minus voltage. The neutral wire sitting there at 0 volts to complete the circuit. Now, those 2 wires on their own would be enough to make a circuit work. So what's the yellow and green earth wire doing? Well, it's a safety wire. And it's one of the safety features that plugs have. And it's there to stop anything that's plugged in from becoming live. So if there was a fault inside your toaster or your cooker or your fridge, and the electric current was flowing around the metal outside of that fridge or that kettle, you could get an electric shock which could kill you. Now, the earth wire is there to stop the outside of those devices becoming live. It'll only carry any current down it if there is a fault. It'll carry that current safely away if anything does become live. Now, we only need that for devices which are metal on the outside, something which could become live and give you an electric shock. So we've got our live wire, which sits there being alternating between positive and negative voltage, plus, minus, plus, minus, plus, minus. We've got the neutral wire that sits at 0 volts compared to the live wire. And then we've got the yellow and green earth wire, which is the safety wire. It would stop anything that's plugged in to the mains from becoming live or giving you an electric shock. Normally, it doesn't carry any electric current down it. It would only carry current if there is a fault and it's carrying the current away from the device that's plugged in. So those are 3 wires. You need to know their colors. You need to know the jobs that they do. And that's actually the second page on your worksheet. Here's our worksheet. Oh, there it is there. So the 3 wires in a plug, you need to make sure you've got all the notes about the information about the voltages, the colors, the jobs of the 3 different wires in a plug. So again, if you want to, you can pause the video So you've got those notes in front of you and they can go onto your worksheet. And after you've finished getting the notes onto the worksheet, you can unpause the video. So get that second page of your worksheet filled in now. Right, welcome back. Final stage of the lesson. We're just going to look in a bit more detail at the earth wire. Now, like we said, most plugs in here in the UK have those 3 wires, those 3 pins in them, but there are some which only have a live and a neutral wire, then they don't have that earth wire. Now, why do some things have an earth wire and some things don't? Well, like I said, it's because you only need an earth wire of something which can give you an electric shock. So it must have metal on the outside of it, an outside part of it which can become live. So your toaster or your fridge, they're metal on the outside and can give you a shock, but a hairdryer is plastic on the outside and couldn't give you an electric shock. So your kettle and your fridge will have an earth wire, but your hairdryer won't have one. So let's have a look at how an earth wire actually helps us if something does become live. Let's imagine our toaster here. Okay, so we've got our toaster. Now, normally, what happens in something which is plugged in, we've got our live brown wire, we've got our neutral blue wire, and normally the live wire carries the current in, and then the current flows back out through the neutral wire. We've got a nice complete circuit. Current flows in along the live wire, out through the neutral wire, and we've got a nice complete circuit there, all nice and safe. However, if something goes wrong inside the toaster, if that live wire somehow got broken or it was touching the casing, the metal part of the toaster, suddenly we've got a live metal outside case of the toaster, and if someone touches that, the current would flow through them and give them an electric shock. So the earth wire is there to stop that happening. The earth wire is actually connected to the metal case. So it's literally just screwed into the metal case. Now, what would happen is that electric current, if there was a fault, the electric current would flow down the earth wire. And the earth wire is literally plugged into the earth on the outside of a building. So the earth wire would carry that current away from the metal case and stop you getting an electric shock. One other thing that happens in that case is because when the current flows through the earth wire, it lets a great big current flow that actually blows the fuse as well and stops the toaster or stops whatever is plugged into it from working. So really it's doubly safe because first of all, it would carry the electric current away to stop you getting a shock, and it would also let a big current flow through the fuse to blow the fuse and stop the device working altogether. So an earth wire helps to keep objects with a metal case safe and stop them being able to give you an electric shock. And that's your last job on this 3-pin plug worksheet. You'll see the last page on the 3-pin plug worksheet, if I get that up, is actually a little summary about how the earth wire keeps it safe. It's got 3 sentence starters. If the live wire becomes loose, connecting an earth wire to the casing prevents the case becoming live because, and plastic cased appliances don't need an earth wire because. Those 3 sentences to fill in to explain how an earth wire keeps us safe, and those are your tasks done for today. So please make sure that once you can rewind the video to fill in anything that you missed. Please make sure at the end of finishing all your worksheets that you submit those worksheets to me, your calculations, and the 3-pin plug worksheet that you've just finished, so I can have a look at what you've been doing and give you any feedback that you need. Please leave me any comments or questions here on Google Classrooms, and I'll see you next lesson. All the best.